Let's look at how to write out some fusion reactions on paper. Okay, so the question says sketch the fusion reaction between two H2 atoms. And so what we want you to be able to do in class is to uh, write out that shows like two of the atoms, like what they would do when they fuse together. And so we're going to write a nuclear chemical equation to do that. And so the first thing that you're going to have to do is you have to write down the symbol of the atoms that are fusing. So what we're going to do is we're going to write hydrogen. Remember that the 2 at the 2 in the name, that is the mass number. All right? And so the mass number goes up here. Now, you could look at a periodic table if you wanted to, and you could see that the periodic table, if I click on hydrogen and bring it up, hydrogen has the atomic number of 1. All right, so that's going to be right here. The atomic number is going to go down here. All right, and that's the number of protons. Remember, the mass number is protons plus neutrons. All right, so maybe I should just label that here. This is the atomic number down at the bottom. All right, that's the number of protons, and this up here at the top, that's the mass number. All right, so we're going to have two hydrogen 2s. So one hydrogen there and one here. So they're going to go together. Now, what's going to happen is you have to add together the number of protons. All right, because basically what you're going to have is you're going to have something with one proton here, okay, in the nucleus, and since it's hydrogen 2, it's going to have one neutron, okay, one proton, one neutron. That's going to fuse together with another hydrogen that has one proton and one neutron in the nucleus. And so, anyway, that's going to make something over here, and it's going to make a bigger atom because you're having two smaller things. Make one, and what it's going to have two protons, okay, because the protons just can't go away, and the thing's going to have two neutrons. All right, so anyway, we don't really need you to draw out these circle pictures like I'm drawing, but what we need you to be able to do is to figure out what's going to be produced. Okay, and so what we're making, it's going to have 1 plus 1. It's going to have 2 protons. So we know the atomic number of the new thing is 2. So what we would do is we'd go back, we'd look at a periodic table. And so if I click back on the periodic table, or you look at one, you would see that helium has atomic number 2. All right, and so we know that we're going to make helium. Okay, always go by the atomic number as to what you're going to make, not the mass number. All right, so what we would do then is we would write helium's symbol right here. All right, and then we would figure out the mass number by adding up the number of protons plus neutrons, which is the mass number here. So we can go 2 plus 2 is 4. Okay, so when we ask you to do this, we're looking for you to do this thing here that I'm circling, not to necessarily draw these pictures down here. But if the pictures help you, you could do that. All right. Okay, let's try another one here. Okay, so let's sketch the fusion between a zinc 65 and an indium 115. All right, so what we would do is we'd write zinc. Remember that the dash number is the mass number, so we're going to go 65 up here. I don't know the atomic number. I'll have to look that up in a second. Plus an indium 115, so an indium 115. All right, so now I'm going to click over to the periodic table. I'm going to figure out what zinc's number is. Okay, so zinc is number 30, and indium is number 49. So 30 for zinc, 49 for indium, because I'm looking for the atomic numbers. Okay, so I can go back here, and I could say, okay, well, zinc's number is 30, so I'm going to put that right here, and indium's was 49 right here. All right, so what that's going to make, it's going to make something with 30 plus 49 protons. So we go 30 plus 49, we're going to add together the protons. Okay, so that something that we made has 79 protons. And then we add together the numbers at the top to figure out what mass number the new substance will have. So 115 plus 65, and that's 10, 6, 7, 8. So it's going to have a mass number of 180, whatever we produce there. Okay, let's go back at the periodic table and see what new species we made. So whatever substance is number 79? Oh, that's gold. All right, so we made gold. All right, and so we would go back and we would put the symbol for gold right here. Now, these fusion reactions that I'm doing right here are just hypothetical, and I'm not saying for sure that these would actually happen, but with the species that I wrote over here to the left, this is what you would get as long as no additional products are produced. All right? Okay, let's try one more. Okay, so this one says, sketch the fusion between a mercury 203 and a helium 4. One neutron is emitted during product formation. All right? So anyway, we would do mercury 203. So we write mercury, and we know that it's 203 right here, and I got to look up the atomic number there, plus helium 4. So we know it's helium 4. All right? I know helium is atomic number 2, but I don't know what mercury's is without looking, so I'm going to look. Okay, so I find mercury. Mercury is number 80. All right, so I'll put that right there. So I know that this is mercury 80. Now this one has a little bit of a twist to it because it says one neutron is emitted during product formation. All right, so our new species is going to have 80 plus 2 protons, so we can write that right there. All right, we can look up and see what number 82 is. All right, so we find 82, that's lead. So we know it's going to be lead, so we'll write lead down. So we know that it's lead. So anyway, and then we also know, before we do the mass number, we know that one neutron is going to be produced. Okay, and so a neutron, remember, has a mass number of 1, but it doesn't have any protons in it. Okay, and so now this 203 plus 4, okay, so we got 203 plus 4 is going to be 207. So we have to follow the law of conservation of mass, which means if we have 207 on the left side of the arrow, we have to have a mass of 207 on the right side. But this neutron right here is taking one of the mass numbers, because a neutron has a mass number of 1. And so our mass of our lead over here has to be 206, because 206 plus 1, so if we add those together, that's going to equal 207. And 203 plus 204, that equals 207. So the mass on the left has to equal the mass on the right in this case. All right, so we get lead 206. Okay, that's it. I hope you have good luck with these.